Let us perform some activities. Activity 1. Let us first take a beaker and fill it with water. Now, dip some portion of a pencil vertically in water. Let us look at the pencil carefully. We observe that the thickness of the portion of the pencil in water appears to be more than the thickness of the portion of the pencil that is outside the water. Let us now keep the pencil inclined to the water surface so that it is partially immersed in water. We observe that even this time the portion of the pencil inside the water appears to be thicker than the portion above the water. Also, the pencil appears to be broken at the surface of water. What can be the reason behind these observations? Let us first perform another activity and then discuss about it. Activity 2. Let us first take one metallic vessel and keep one coin in it. Now, slowly move away from the vessel and stop at the place from where the coin appears to have vanished. At this distance from the vessel, the coin is not seen. Keep looking in the direction of the coin and ask your friend to slowly fill water in the vessel. We observe that the coin in the vessel is seen once the level of water reaches a certain height. Do you know why does this happen? In both the activities, the effects seen are due to the change in the direction of light while coming out of water. Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. Come, let us know about it in detail by performing another activity. Activity. Let us first fix a white paper on the drawing board with the help of drawing pins. Now, keep a glass slab on the paper and draw its outline PQRS. Let us now draw an inclined straight line on the side of PQ in such a way that this line intersects PQ at N. On this line, let us pierce two pins vertically at 2 points A and B. Now, look at the pins A and B from the opposite side of the slab and pierce pins C and D vertically so that the images of A and B are in line with C and D. Next, remove the glass slab and pins and draw a line going through points C and D so that it intersects RS at M. Let us now join points M and N. Here, ray AN is the incident ray and ray MD is the emergent ray. Observing these rays, we come to know that the incident ray and emergent ray are not in the same straight line. This happens because the refraction of light takes place when the ray of light is going from air to glass and from glass to air again. Come, let us discuss about it in detail. In the activity of refraction of light passing through a glass slab, light gets refracted twice. The first refraction occurs when the light ray enters the glass from air at N on side PQ. The second refraction occurs when light enters air from the glass at point M on side RS. Before proceeding further, let us know about the angle of incidence and angle of refraction. The angle between the incident ray and normal to the surface at the point of incidence is called the angle of incidence. whereas the angle between the refracted ray and the normal to the surface at the point of incidence is called the angle of refraction. Here, for the first refraction, the angle of incidence is I, while for the second refraction, the angle of incidence is I1. The angle of refraction at n is R. Note that the angle of incidence at M, that is I1, is equal to the angle of refraction at n, that is R. In the second refraction, the angle of refraction is E, which is equal to the angle of incidence n, that is I. The extent of change in direction of the ray of light at the opposite parallel sides PQ and RS of the glass slab is equal and opposite. Due to this, the light ray MD emerging from the glass slab is parallel to the incident ray AN on the side PQ of the slab. But the emergent ray is somewhat displaced, that is, shifted with respect to the incident ray.